Section 7.2 is about ratios and complements. And again, you're going to have a quiz after Section 7.3, so after the next section. Okay, so again, you have two pictures here, and we're going to use these two pictures to talk about three vocabulary words. We've talked about one of them already in the last section, the hypotenuse. The hypotenuse is always across from the right angle. Again, it's always the one that you should look for first, just like we did when we were talking about the Pythagorean theorem. So no matter how your triangle is situated, again, directly opposite your right angle is the hypotenuse. Okay. Adjacent is always next to the angle in question. Okay. So in this left-hand picture, here is the angle that I have something for theta here. Okay. So again, right next to that, two things that are sort of kind of next to it would be this side and then this side. But again, this can't be next to it because it's already the hypotenuse. So that's why this is the adjacent to that. Okay, and then directly opposite that angle, again, if I go directly opposite that angle, there's my side opposite. Okay, if I look at my other triangle, again, the hypotenuse is already labeled. So if this is the angle in question here, again, the side that's going to be right next to it, again, it cannot be the hypotenuse. Again, once we have the hypotenuse, something can't be the hypotenuse and the adjacent side. So the angle that's right next to that, the side that's right next to that angle, is this one right here. That's why that's labeled adjacent. And directly opposite, again, straight across, is opposite that angle. Okay, so for each triangle, we're going to label the appropriate sides as the hypotenuse, the opposite, and the adjacent with respect to the marked acute angle. So again, in this first one, I want everything in relation to R. Okay, so again, always easiest to find the hypotenuse first, directly across from the right angle. So that's going to be my hypotenuse. And again, you can always abbreviate hypotenuse HYP. Okay, it doesn't matter which one that you find next, but again, this is relative to R. So how about we go directly opposite? So directly opposite R is here. So that would be my opposite side, which by process of elimination leaves that to be my adjacent side. And again, that's right next to R. So that's why it's the adjacent side. Okay, for B, again, we'll find the hypotenuse first. Directly opposite the right angle is my hypotenuse. So again, in this case, I'm concerned about this angle F. Let's do the adjacent first for F. Hey, again, the hypotenuse can't be the side adjacent. So the only other side that's next to that angle is FD. So that's our adjacent side. And again, directly opposite angle F is DE. So that's going to be your opposite side. Okay, so what is trigonometry? Hey, it's the study of triangle measurement. Hey, which sides and angles. So we're going to have three different things that we're talking about here. Sine, cosine, and tangent are the three main functions in trigonometry. Hey, they're used to find sides or angles in right triangles. Again, this is only going to work if you have a right triangle. So when we're talking about sine, cosine, and tangent, they are always abbreviated. SIN for sine, COS for cosine, and TAN for tangent. Okay, and you're going to have three trigonometric ratios then. Again, ratios are just fractions. Okay, so we're going to have something for the sine, we're going to have something for the cosine, and we're going to have something for the tangent. So this S, again, represents the sine, this C represents cosine, and this represents tangent. Okay, so all together, if you put these three things together, it spells this word that we like to say as mathematicians, SOHCAHTOA. Okay, so that tells you how you're going to find your three trigonometric ratios. Okay, so what does this really mean? Again, the sine of theta, the sine of your angle, is going to be equal to the letter O stands for opposite, and the H stands for hypotenuse. So the sine of theta is going to equal the side opposite that angle divided by the hypotenuse. The cosine of an angle, the A stands for adjacent, And again, the H stands for hypotenuse. So the cosine of an angle is going to equal the side adjacent divided by the hypotenuse. And tangent, again, the O is opposite, the A is adjacent. So the tangent of an angle equals the side opposite over the side adjacent. Okay, so those are your three trigonometric ratios. You cannot switch anything around. So you can't put the hypotenuse on the top there and the hypotenuse on the bottom. There is no other option. These formulas are set in stone. Okay, and again, there's a picture of our angle down on the bottom. So again, if this was our angle theta, directly opposite that, the hypotenuse would be the side across from that right angle. And then right next to it, we have our adjacent side. Okay, so how are we going to use this? Let's find each ratio. So again, I'm just going to write SOHCAHTOA on the top here so that you can see it. Okay, so the first thing that I want is the sine of t. So again, I'm just going to put an arc through t so I know what I'm talking about, and I'm going to underline the sine part. So the sine of t is going to equal the side opposite over my hypotenuse. So directly opposite t is 7, and my hypotenuse directly across from that right angle is 25. Hey, it says find the ratio. Ratio you can leave in fraction form, so let's leave that as 7 over 25 for the time being. The next thing I need to find is the cosine of t. So let me get rid of that line too. And this time I'm going to concentrate on the three middle letters. So CAH. So my cosine of t is going to equal my side adjacent to t over my hypotenuse. So adjacent to t, again, it's usually easier to find the hypotenuse first. That 25 is still going to be my hypotenuse, which means in relation to t, the side that's next to that is going to be 24. So 24 over 25 is going to equal the cosine of t. And now I'm going to switch angles. So let me again erase my picture, and I'll change my color. Let me erase the underline there. Okay, and I'll change my color. Let's do purple. So now I need the tangent of C. So now we're talking about everything in relation to angle C. So the tangent of C, that's this piece here, that's the TOA, is going to equal the side opposite over the side adjacent to C. Again, no matter what, this piece right there is the hypotenuse. Okay, so the hypotenuse is not going to come into play in the tangent. The side directly opposite is 24, and my adjacent side is going to be 7. So 24 over 7 is going to equal my tangent. Next, I need the sine of C. So again, we're still talking about everything in relation to C here. And it's this. And I need the sine. So again, I need the opposite over the hypotenuse. So directly opposite C is 24. And again, the hypotenuse, the side across from that right angle, is 25. So the sine of C is 24 over 25. The next thing that I need is the cosine of C. So again, still talking about that side C, but this time the cosine is this middle part right here. That's the AH part. So I need the side adjacent over the hypotenuse. So again, right next to C is 7, and the hypotenuse, the side directly opposite that right angle, is 25. So I have 7 over 25. Okay, and my tangent of T. So I'm going to switch angles now. So let me switch all that. And again, I'll switch my color. I'll do orange. So now we're concerned about T here, and I want the tangent of T. So I'm concerned about the OA. So I need the side opposite over the side adjacent. Okay, so the side directly opposite T is 7, and the side adjacent to it is 24. Okay, so 7 over 24 is going to equal my tangent. Okay, so before we move on to our next slide, we want to describe any patterns that we see. And what do you know about the sum of the measures of angle A and angle, of angle C and angle T? Okay, well, this is a right triangle. Okay, so again, what does that mean? That means that this angle is 90. If there's 180 degrees in that triangle, if I take the 90 that I've already used for this right angle away from that 180, that means that there's 90 degrees left to split between C and T. Okay, so the sum of C and the sum of angle T always, as long as this is a right angle, those two other angles are always going to have a sum of 90. Something about that's going to come up later inside this section. One other thing that I notice, I notice some of my ratios are the same here. For example, I have 7 over 25 here, and I have 7 over 25 here. Sine of T is 7 over 25. The cosine of C is 7 over 25. Look at this one here, 24 over 25. That happens one more time right here. 24 over 25, the cosine of T and the sine of C. Okay, and then the other thing that you can see here is this and this are reciprocals of each other. In other words, again, if I take the flip of it, they would be the same thing. So again, those are reciprocals of each other, and that's your tangent of C and your tangent of T. Okay, just keep that in mind for, again, later in the video here. Okay, so your calculator is going to be able to do a lot of the work for you here, but it must be in degree mode to be able to calculate your trig values, okay, since they're all in degree measure. So in your calculator, it's pre-designed to be in radian mode. So what you're going to do is if you have the TI 83, 84, you want to hit the mode key, which is over here. And then inside there, I should change my color because that really didn't show up. There's your mode key right there. And then inside that, we have to change this radian to degrees. Okay, so once you hit mode, you're going to hit your down arrow till you highlight the radian. And then once you highlight radian, you're going to hit the right arrow one time to highlight the degree like it is in this picture here. Okay, and then after you highlight that, all you have to do is hit enter and your calculator will be in degree mode. If you are using your cell phone as a calculator, okay, it has what you need. It has the scientific calculator in it. You have to turn, when you're in your calculator app, you have to turn the screen to make the sine, cosine, and tangent pop up. I'll show you the buttons that you need in 1 second. You need those sine, cosine, and tangent. If you have your screen lock on, when you rotate your phone, that calculator is not going to show up. So you have to have your screen unlocked in order for your cell phone calculator to change into a scientific calculator. Okay, so we're going to use the calculator to find these values. So again, I'm going to go into my calculator app and try to show you. And it's the same buttons that you'd be pressing inside of your cell phone calculator. But again, play along. Make sure that you get the same exact answers that I get, because if you don't, something is wrong. So if I go into my calculator, again, I'll hit clear so everyone's starting from the same thing. I'm going to hit mode. And then I'm going to go down till I have radian highlighted. And then I'm going to go to the right once. And I'm going to hit enter. Okay, to get out of this screen, I'm just going to hit second and then quit, which is above the word mode. And I'm back in the regular calculator part. So the first thing in that chart that we wanted to find was the sine of 10. So all I'm going to do is hit sine, 10, and then enter. Okay, so you do the same thing again on your cell phone. Just find that sine key and then hit 10 and then hit enter, and that's what you should see. If you don't, something is wrong. Again, we can talk about it during class time if you need help figuring out that calculator. Okay, so when we're talking about trig functions, we're always going to round to 4 spots after the decimal. So I'm going to go back into my presentation. So again, I just found the sine of 10. It was forward to 4 decimal spots. It's 1736. Hey, again, I'm not going to keep going in and out of the calculator just to save time. But again, you should definitely check and make sure you're going to get the same answers as me. The cosine of 10 is 9848. The tangent of 10 is 1763. The sine of 40 is 0.6428. The cosine of 40 is 0.7660. The tangent of 40 is 0.831. 8391. I forgot the 9. Sine of 50 is 0.7660. Cosine of 50 is 0.6428. The tangent of 50 is 1.1918. The sine of 80 is 0.9848. The cosine of 80 is 0.1736. And my tangent of 80 is 5.6713. Okay. So again, I'm just going to point something out before I switch slides. Couple things repeated itself in here. I have this and this. I have this and this. Okay, so you can see the same number repeated a couple times inside the calculator. This and this. Okay, so again, just keep that in mind as we go further into this video. Okay, so here's this further into the video. So this is what I've been kind of alluding to during this entire video here. Okay, so the acute angles of a right triangle are always complementary. Again, what does complementary mean? They add to 90. We talk about supplementary an awful lot. We did talk about complementary earlier in the year, but now it's going to start coming up more. So again, it's a compliment to tell me I look like I weigh 90 pounds. That's how you'll remember that complementary angles add to 90. So here's what the deal is. Okay, if A plus B equals 90. So again, if your complementary angles in that right triangle, if they're 90, which they are, then what's going to happen is the sine of angle A is always going to equal the cosine of angle B. Okay, so the sine of one angle is going to equal the cosine of the other angle. Okay, and again, not your 90-degree angle, your two complementary angles, the two acute angles. Okay, so how would that help you in these questions? So I want to find the value that's going to make each statement true here. So I want the sine of theta if the cosine is 32 degrees. Okay, well, all I'm going to do is I'm going to take my 90 and subtract out 32, which means 58 is going to be, the sine of 58 is going to equal the cosine of 32. So the sine of 58 equals the cosine of 32. Again, this is really like x, so we were just kind of finding x there. So that's why I took that out. So the sine of 42 equals the cosine of x. This time I used an x. So again, complementary angles add to 90. Subtract out the 42 degrees that you already knew. That means that you have 48 left. So the sine of 42 is going to equal the cosine of 48. Okay, and then for C, again, if you don't like theta, just put x's in there. Okay, so I have the sine of x equals the sine of x plus 20, and I want to solve for really theta, but I want to solve for x. Again, if I add these two angle measures together, they have to be 90. So all I'm going to do is add x plus 20 and set it equal to 90. Or 2x plus 20 is going to equal 90. Subtract 20 from both sides, and 2x is going to equal 70. And then I'll divide both sides by 2, and x is going to equal 35. Okay, so for part D, same exact thing is going to happen here. I have the sine of x equals the cosine of x minus 30. So again, these two things have to be complementary. So x plus x minus 30 is going to equal 90. Or 2x minus 30 equals 90. add 30 to both sides. 2x is going to equal 120. And then the last thing that we'll do is divide both sides by 2, and x is going to equal 60. Okay. I suppose I should write out D and C the way I did A and B as well. Okay, so the cosine, again, x theta in this one was 35. So the cosine of 35 is going to equal the sine. If x is 35, 35 plus 20 is going to equal 55. So the cosine of 35 equals the sine of 55. And the 1D here, we'll have the sine of 60 equals the cosine. Again, if x was 60, 60 minus 30 is 30. So the sine of 60 equals the cosine of 30. Okay, and here is our last question. So in a right triangle ABC with the right angle at C, and the sine of A equals 2x plus 0.1, and the cosine of B equals 4x minus 0.7, we want to find the value of x and explain the answer. So again, might be helpful to have a picture here. And again, normally I say it doesn't matter what you put where, but again, just make sure that you're labeling your right angle C. Other than that, it doesn't matter where you put A and B. Okay, so what do I know about A and B? A and B have to be complementary. Okay, so they have to add up to 90. Okay, and again, the sine of A and the cosine of B are going to be equal to each other then. So the sine of A equals the cosine of B. Okay, and again, I'll subtract 2x from both sides, and I'm going to have 0.1 equals 2x minus 0.7. Hey, again, it doesn't matter what you, it doesn't matter what you do next here. We have to add the 0.7 to both sides. It doesn't matter what you do first, it matters what you do second. So we're going to have 0.8 equals 2x. And again, anytime that I'm doing decimals, always put it in the calculator because it's so easy to make a mistake. When you divide both sides by 2, you should get an answer of 0.4. So again, explaining my answer, the sine of A equals the cosine of B. So x equals 0.4, and you're done. Okay, that's it.